All right. Thanks, Pankaj, for inviting me for this lecture. I heard from some students that he hyped me up as the co-pilot expert, and someone thought that the CEO was coming. So I'm sorry I had to disappoint you. But today we'll be talking about how to build applications with language models. Quick introduction for myself. I'm an engineering manager at Verto Health. I lead the sales engineering and product innovation space. And recently I've been leading our healthcare AI team to automate system integration. I started teaching here since 2022. I have taught 2 courses, CSCC01, where we got to contribute to LangChain. And also, I'm currently teaching C09, so I see some familiar faces here. So, yeah, hopefully you're not too bored seeing me. Okay, so kind of want to go through kind of the basics of large language models before we, officially start. So for large language models, there's 2 pieces that we need to know. Okay, so first of all, is that large language models are trained on a very diverse range of text data sets, whether or not it's the Wikipedia, whether or not we do it through web scraping, whether or not a human will manually actually create the training data, or the recent scandal that happened just a week ago about Slack using their customers' data to train their AI algorithms. It can be, there's various ways to come up with that source data. And this is essentially what differentiates these language models, what we've seen with each other, right? So you've heard the Llama, you've heard the Mistral, you've heard the GPTs and whatnot. It's really about the training data. The second piece, which is I think less important and is really well documented, how next token prediction is done. I have those 2 links for those who are interested in the math behind it. It's really just powered by matrix multiplication and nothing else magical, okay? But we've actually done next token prediction before. I don't know who recalls in AO8 we've done this thing, generating a random story. It's how I got into. I took AO8 in 2016, and it's how I really got into loving text generation. But okay, doesn't matter. Here's how it kind of works, right? Here's the graph on the lower right-hand corner, which is you have some training text, and then for that training text, what is the probability of the next word, right? So if in the training text, 99 times we see world after hello, then our graph looks like this, right? 99% of the time it will generate world. 1% of the time, if the training data exists, it will say hello, Pankaj. Something like that, right? So in the LLM world, you could kind of think about it as a graph like this. The graph is not there initially. It's just matrices, but you can think of it as a graph that will generate the next word based on what probabilities, based on what you see in the training data. Okay? Okay, so let's go into language model and kind of like try to formally define what it actually is. And you can see these examples I've said, for large language models, now we have a lot of buzzwords, right? So just making sure everyone knows the buzzwords. Large language models are models with a lot of parameters. So example would be like GPT-4. We don't know how many parameters it's trained on, but we assume it's very big. We have Llama 3, 70 billion. Mixtral 8 times 7b, which is like 56 billion. And these are really heavy models. They're trained on a lot of texts, and they go through many layers of propagation before giving you a result. So they're very slow, but they are, you could say it's smarter, okay? Then you have this new class of models coming in, as I think is in recent months, called small language models. And it doesn't contain too much training data, but the training data that they supposedly train it on is higher quality. It's no longer a dump of everything in the web. It's high quality text that will give you, the aims to give you higher quality prediction, but is faster to generate. right? So definitely not as smart as the large language models, but the idea is that it's good enough for the use case. Okay, for all of these models, they follow one function definition. I think is really good to visualize with this one function definition, which is just a generate function. It takes in one parameter called the prompt, comes in the form of a string, and the output of this generate function is a string. Okay, the string you could say, oh, is the prompt plus additional characters or just the additional characters? It doesn't matter, right? In the end, it's just string to string function. Just before I lose anyone, who here has never opened ChatGPT in their life? No? Yes? Really? Well, I think it's okay. After this lecture, maybe you actually try it out. That's interesting. Okay. I think people have been overusing it rather than underusing it, but we'll see. Okay. Turns out this function, you know, it looks easy, but you can actually do a lot of things with this function. So three really interesting things you could do with this function. First of all, you can control how the prompt looks like. And it sounds very obvious that you could do that, but in 2020, when GPT-3 first came out, nobody knew that this was possible. To do prompt management, to really put the user input, so there's user input, and we add things to the user input to make the generation more contextual to what we want. There's also post-processing, okay? So the string that's outputted, we can turn it to JSON, for example, where we can turn it into an object, we can parse it out, we could do a lot of things with it. It's not just limited to a string. This string can have multiple formats. And finally, chaining all of them together. So calling generate with the result of the previous generate and so on and so forth. That's another thing that we could do. And we'll go through how we could utilize it in a production application. One question is, and this is what drives my presentation over here, is the next token prediction good? Okay, and so it's really fun in games when you talk about, okay, it's just this function that I could use, it's like magic, and hopefully after this we think less of it as magic and more of it as like a helper for us to develop applications. But what it predicts is not magic. It doesn't know anything, right? It has no context. For example, if the training data does not have the instructors for UTSC, then when you ask the model, you know, who is the current instructor of CSCC01 at U of T, it likely will get it wrong, right? And so if it gets something wrong, and the buzzword here is called hallucination, when the LLM hallucinates, then that's not good. That does not satisfy what we want it to be, right? An all-knowing string-to-string autocompleter, right? So I want to go through 3 solutions today into making this next token prediction better, okay? So going into the first one, fine-tuning LLMs. Okay. So in fine-tuning, what we want to do is provide more text for the LLM so that it can answer the questions you want. So providing more base knowledge for the LLM. Recall I've talked about the LLM is it's purely based on training data. Okay. In fine-tuning, I want to give it more training data. Okay. But I'm not retraining the LLM. I'm adding to it. It's like the sugar on top. I'm adding more training data. So when I use this fine-tuned LLM, it will give me more or less things that I've fine-tuned it on. Okay. So let's take a look at this example. I just want to visualize it before I go on to it, which is previously, hello, I have 99% going to world and 1% going to Pankaj. Okay. With the fine-tuning, I'm adjusting the weights of this graph. Instead of 99 to world, only 25% to world, and 75% will go to Pankaj. Okay? So the internal kind of like percentages, as we call the weights, are being modified to suit to our standard. Okay, so in this case, let's take a look at how we could fine-tune an LLM. So first of all, we need high quality text. Okay. So for example, if I want to build a question and answer bot, the text I will be giving them would be in terms of a text blob, again, string to string, right? So we're only giving them a series of strings to fine tune on. On the left side, I have one example, right? It's a Q&A pair. So for example, if the Q is this question, then the A is that. This is my second thing. And obviously I won't have two. I will have tens of thousands, right? Your best effort, give it as many as possible. And then next time the LLM sees the question mark, it does know to change the weight so that it gives a new line and then A and then colon for the auto completion to work. So the most obvious modification to this fine-tuned LLM would be when you see the question mark, the LLM will give a higher weighting to a new line character followed by a capital A, followed by a colon, followed by a space in the auto completion. Okay. Clear as mud. Okay, so all right, the second thing, we have the training text, we have tens of thousands of it, we have hundreds of thousands of it, okay? Now is the time to actually do the fine-tuning. So here you need good GPU and good hardware. Can anyone tell me why do we need a good GPU in order to perform fine-tuning? Exactly. GPUs are really good at doing matrix multiplications because there are a lot of parallel computations that CPUs cannot do. Okay, so you need a very good GPU. When you're training large language models, then you need a really modern GPU, like perhaps an H100. But if you're fine-tuning small language models, it's sufficient to use something like an A10, the older version of a GPU, or A100. Granted, they're not cheap, but there is, I think, generous free credits that you can get with like Paperspace or Lambda Labs that is cheaper. They range around from like $1 an hour to like $48 an hour or more. So make sure you turn them off at night. I got burned by that. The company footed the bill, so it's fine. Okay, so you have a good GPU hardware, you have good training data, and finally you need to find a script to run it. And the reason why I'm not doing a demo here is that now like fine-tuning LLM is so commoditized. You can go on GitHub, find the right Jupyter notebook for it, find the right app for it, and then you could just do it. You do not need any sort of technical knowledge. And in fact, my director of product, which doesn't have a computer science degree, is fine-tuning LLMs on his own. So that's fine-tuning. So that really is about modifying how the generate function works, right? As I go back here, this is kind of like the whole thing about LLM. Fine-tuning is about modifying how this function works internally, modifying the weights. Now we have the second one, which has nothing to do with LLMs. Okay. Now it's talking about what is the input to the LLM, the prompt itself, right? Usually you like to type whatever you want, but in this case, what someone came up with is, well, without retraining the LLM, can I just inject more context in the prompt? So here's the example prompt, right? Answer the question given the following context. And I have Pankaj, CO1, Choyin, CO9, okay? And the user input is not the prompt I'm going to use. It's actually going to be put into this section that I have under there. Given this context, now answer this question. Okay? And so, as expected, with this change, just by changing the prompt, I get a much better answer, right? Again, noting that obviously I'm creating the prompt by hand, but what you do in your application is that this part over here, this question over here is the only thing you type in your application. Okay, over here. And then the user will not see this prompt. This prompt that over here, you could assume it's like the user doesn't see it. So let's just blur it out for the sake of it, right? The user does not see it. So what we call, the buzzword for this again, I think it's good to learn the buzzwords because when people are talking about it, you're, oh yeah, I know, yeah, that makes sense, right? This particular method of adding context to the prompts is called retrieval augmented generation, RAG in short. It's like, so when people say, oh yeah, RAG it, then what they mean is just, okay, I'm going to inject more knowledge into the prompt, more context in the prompt, so that when I do when I kind of put my user input into the LLM, it actually gives me something contextual. Okay, there's many ways in which you could do RAG. So for example, you could given the user input first do a Google search, okay, or you could do in some other search. So the most popular way right now in this LLM hype is doing vector searching, okay, which I don't want to get into, but it's something really worth looking into. Okay, so we have, first of all, how to fine-tune the LLMs. We have how to make better prompts. And the third one, I think it's relatively new right now, is output control. Okay, back in the days when we used GPT, we couldn't control what the output was. We had to specify in the prompt to, like, let's say, return this information in JSON or return to me in this particular format, and you give it examples. There's a chance that it doesn't fulfill your request, right? So here's an example. I said, return this result in JSON format. It gave me the open bracket. It gave me the key, which really isn't in the format I want. And it forgot the close bracket, right? And if I want to utilize it in my application, most of the time I would want it to return in some sort of structured format, right? So with the traditional sense, not very good. Okay, it will throw me an exception because when I do JSON.parse, it doesn't work, right? It's missing the close bracket. The solution here when productionizing LLMs is to force the LLM to return the results based on a defined pattern or based on some grammar. So these are links to the various libraries that you can use to constrain LLM outputs. And it's super important because you always want to figure out those edge cases when the LLM is not really functioning to how you expect. Okay, so this is probably regex. You could do regex, and for GBNF, that is going to be in the Bacchus NOR form, which I think you're going to learn more in C24. But again, very, very easy to understand so far. So quick kind of like internals, how does it work? Again, it's about observing this graph here on the bottom right. So let's say after that double quotes, 90% of the time the LLM says, yeah, go to end of string, do nothing, that's the end. 10% of the time it goes to a close bracket, right? When you apply these libraries into constraining your LLM output, it will always prioritize what you have over here. So if it's 10%, it will force. It will just, not force, but it will just make sure that it uses the close bracket, the close curly bracket in the JSON. And in the case where this is 0% and is then a string, it will do the same thing. The library will automatically try to fix the format for you. Okay, so that's output control. So with these three things, the idea is that you could build something that is more production ready. Okay, let's look into the first case study. So let's take a look at an LLM architecture, an SLM architecture to generate a random story. So first of all, let's utilize what we've learned. Okay, so prompt building. First of all, we need to have a title of the story, synopsis of the stories, maybe names of characters we want. Let's put it through the GPT 3.5 API, and then we do some sort of output parsing, right? Like, for example, we split the output into pages, or well, after we split the output into pages, maybe we can add some more picture illustrations using text-to-image API. It's possible. Oh, I've taken this from my previous CO9 semester where somebody was generating a story. So please do not plagiarize this idea in your CO1 project. Okay, so this is the architecture. Everyone clear with that? So let's take a look at my example prompt, right? Again, prompt it with the right things will give you higher chance of success. You're a short story writer. Given the following synopsis and characters, generate a full story. Start with once upon a time and end with they lived happily ever after. Okay, so let's take a look at what my sample synopsis is. Let's have some fun. Okay, a software engineering class is taking a final exam. Alice didn't want to take the exam and plot to sabotage the exam so everyone can get 100%. Does Alice get away with it, or do they have to face severe consequences with the university tribunal? All right, so I have my chat GPT over here. Let's see what it generates, right? All right. Paste. Let's just do that. We're not too sophisticated here. Okay, and it obviously will generate, I've tried this, it does generate a realistic story. Oh wow, this is much longer than I initially tried. Okay, let's take a look. So my first story that I generated, Alice got like an award for exposing the university's stuff, but in this story, she was put on academic probation. That sucks. Okay, either way, a story is generated. Okay, but here's some questions over here, right? So first of all, the thing is, with creativity applications, you pay the least attention in the output, right? Because they're hallucinating, you want it to hallucinate, you want it to be creative, right? But something in my story here is, well, first of all, will you generate an incomplete story, right? Will the story end too quickly or go on forever? Is it in the correct length, right? And so I want to maybe do kind of a brainstorming session, right? What are some methods that people would use to, ensure that the output is of sufficient length if they were to design a story generator? Who has some ideas? Yeah, put it into the prompt, right? Write a 500 word. Why don't we give that a try? Okay, new chat. Boom. Keep the story to under 500 words. Maybe we'll do it. It's still going. And then let's search up a word counter. It looks long, but wonder who thinks this works? Who thinks this will work? Who thinks this will not work? Okay. 569 words. Didn't work, unfortunately. Right? This is not foolproof, right? So when you prompt something, it may not do what you expect it to do. I mean, maybe when you do something like you could do some prompt engineering, but again, the results, the mileage varies, right? Like if you keep it under 500 words, you will get a free ticket to the Taylor Swift concert. Let's see if it do now. Again, mileage varies. This worked for me, but again, it depends on whether or not GPT cares about Taylor Swift tickets. It looks like it looks like it didn't work. Okay, just for fun. Do you think it will do better or worse than 569 words? Who thinks it will do better than 569 words? Now there's less people. Who thinks it will do worse than 569? 507! There we go. Although GPT did not get my Taylor Swift ticket, it was able to pull it to a range that's more acceptable. Okay. Okay. So that's the first question, right? And the incomplete story part is very interesting, right? Like this is 500. Nobody wants to read a 500-word thing. What if you want 2,000 words? What if you want more details on, the climax or the rising action, whatever you call it, right? Then you really want the control, okay? The second thing is the limited context sizes, right? If you want to generate a novel, a 100-page novel, one API call isn't enough, right? So let's take a look at, my next slide, okay? I'm gonna talk about English, making a good story, right? I granted I did not score too well on my English exams, but I do remember this, the basics of writing a story. It contains the beginning, there's a rising action, and then finally there's a climax at the very where the main character solves everything, and then finally there's some falling action, and finally the resolution, and they lived happily ever after, right? It's unlikely that you could write a story with one LLM prompt if you want to automatically generate it. So what you may kind of do is, well, can I separate to multiple prompts? Can I have a story, right? I have the synopsis here. And instead of doing that, I could say, write the story, what do you call it? Exposition in under 300 words. Something like that. Let's quickly send that. Alice has always been a free spirit. Okay, either way, this is... I'll read that, but you get the point. Oh, okay, so obviously that's not great. So probably like something I have to do to modify the prompt, right? But in the end, that's not great. You get the point. Prompt engineering required, okay, if you want to really do it. When you do the beginning, obviously is great, but when you build kind of the rising action, you would need the context from the beginning. So this is, again, something that we've learned. We have to rag it, right? We have to incorporate core pieces of the introduction. So then my rising action, it kind of refers back to my introduction in some sort of way. It's not completely random. Because again, when you do a creativity application of sufficient length, usually they lose the plot. And you could try that, right? If you generate the introduction and rising action separately, they're completely two random stories, right? It has no linkage with each other. So this is very important. Here is a pseudocode on how I would do contextual story generation. So first of all, you have the synopsis. I've written that. So maybe in the introduction, you generate, just with the intro prompt and the synopsis. But then when you go to the rising action, you're actually giving, obviously, you need to customize your prompt for the rising action, but you're actually taking the first 50 characters, the last 50 characters of the introduction you've just generated previously, and then you're putting it into, as part of the prompt of the rising action. Or better yet, maybe you could do another LLM summary of the introduction in under 100 words, or just important actions of this particular actor, right? In here, you put it in as context, and then ask it to generate rising action with the context provided. Again, the synopsis here is very, very important here, which is trying to keep the plot, right? You're doing a series of LLM calls. You don't want the series of LLM calls to suddenly, do whatever it wants, right? It has to be constrained. It has to be very constrained. Finally, probably the resolution, same thing. You pass in the climax, you pass in a resolution prompt, pass in a synopsis. So with these three things, maybe we go into something that's more production relevant, because nobody's going to make money with a creativity application. Unlikely, right? Only if you're the first, you may. But if you're the 10th or 100th or 1000th in the market, creativity applications have no production value. Hopefully I haven't offended anyone here. But in the context of LLMs, there is no production value in generating art with LLM. So GitHub Copilot, who has heard and or have used GitHub Copilot before? Okay. Good. So what I do want to ask is, in terms of using LLMs, what strategies does GitHub Copilot use to give user suggestions? 1, LLM fine-tuning. 2, building better prompts. And 3, output control. So let's take a look at a possible GitHub Copilot architecture. Obviously, I don't have access to the source code over here, but what we can tell through, and here's a link to the reverse engineer. What we can tell is obviously we could take a look at the Copilot VS Code extension. So they're doing some sort of prompt building. Okay, so by reverse engineering the VS Code extension, we could see that it actually take the content of your VS Code, of your recently open files, and your open tabs, right? It takes all of that and puts it as part of your prompt. It puts the X lines preceding and succeeding the cursor. Okay, so it's actually contextual, right? Again, part of the prompt. On top of that, it gives metadata, such as the language it wants to autocomplete and or the relative path of that file. So we know where it is, okay? And so before we send this prompt over, there's also a conditionals as you know, front-end improvements is that, first of all, is debouncing requests. So if you do type fast, it doesn't autocomplete until you stop. And secondly, if the user is in the middle of a line, okay, and if you think about it, it makes sense, only send the requests if the characters on the right is a white space or is a closed bracket, right? So if you're in the middle line of your and you're entering stuff, they won't autocomplete unless you're near the end of what you want to write. So a closed bracket, a white space, a semicolon, that's when it actually triggers, okay? And so this prompt is sent over to some sort of inference server. So it's served by a web API, and it runs on what we think is Cushman 12b, okay? Which is actually a small language model. It's a smaller language model anyways, and it's fine-tuned on what we believe is OpenAI/Curie. Okay, actually a very old LLM over there. Okay, and then after that, obviously it does the inference, right? It has the prompt. It runs def generate, and then it returns the top 3 code autocompletions back to VS Code for result parsing. So again, there are safeguards here to not show unhelpful suggestions. So if there is some hard-coded rules in here, hard-coded rules to ensure that they don't display repetitive results to the user. So something like user equals user equals user equals user. Although that's valid Python, for example, it's not actually useful as an autocompletion. And second of all, if the user has already typed the suggestion, just don't show it, right? If they're typing fast again before the results come back, just dump the result and be over with. Okay. Here are some follow-up questions. First of all, LLMs are super powerful. They can actually, if you've taken a look at the articles, they can finish like hard leak code questions even better than ourselves. So in here, why did GitHub Copilot decide to use more of an SLM, a 12 billion parameter one, which is actually small in the grand scheme of things? Larger ones are like 168 billion parameters, 175 parameters, probably 175 billion parameters. So why did they decide to use a smaller model? For speed, right? When you're writing code, you always want to be fast. The developer's not going to wait. They're impatient. You want to perform inference faster, but this is not something that a larger model can do without putting too much money into it, without, it not working out in the cost perspective. My second question is, language models have a limited context window, and usually you can only pass in 4,000 tokens in as the prompt. And I've also said that, if you have 10 recently opened files and they're all 1,000 lines long, it's likely that it's not going to fit. How do you think GitHub Copilot work around this limitation? Doing it by parts. I think that's a very good guess. And so what they do is instead of doing it by parts, so let's say you have 3,000 lines, right, that you've opened, they actually put all 3,000 lines into a wish list section. So it's a staging area. Then, as part of the pipeline, they will prioritize certain things over others. For example, it will actually prioritize function definitions. So it'll just pull out all the function definitions and put it as part of the prompt, and then ask, oh, okay, is my prompt full? If it's full, don't worry about it. If it's not full, continue to populate more and more things. Okay? This is how they work around this limitation. And most of the time, like these small language models will have a smaller, even smaller context window, or maybe they're big, right? Like for those who are nerdy, small language models like Mistral follow a sliding window attention head, and so it kind of slides. So you have like I think up to 16,000 tokens as part of your context window, but again, it has trade-offs, right? And final question about GitHub Copilot is, well, GitHub Copilot is actually trained in all languages visible in GitHub. GitHub Copilot is trained on all public repositories found on GitHub in all sorts of languages. So how can you, perhaps build a better version of GitHub Copilot specifically for your code base? Any suggestions? Have it trained on your private repository. That's a good idea. Are you referring to fine tuning?
Yeah.
Probably fine tuning, right? So fine tuning on your private repository of stuff. What are other methods you can increase the quality of GitHub Copilot? Yeah. That's exactly it. So given it more context. So probably, again, going back into our principles of RAG, right? If I'm auto-completing, maybe I want to fetch the functions that are relevant to me and the function definition and probably some documentation as part of the prompt. And maybe it'll do better, right? These are some kind of ways that you can improve on the existing GitHub Copilot. Okay, so let's take a look at how to best utilize GitHub Copilot, right? Now we know how it's done. Let's solve some, try to solve some real world development problems with GitHub Copilot. And we don't actually need to run GitHub Copilot because to us, hopefully at the end of this, you'll realize GitHub Copilot there is no magic to that. So hopefully, who has taken C73 here? The one on graph theory? Not a lot. That's not exciting. But my first case one is everyone should be able to answer, right? If I if I give this to GitHub Copilot, def shortest path, give it the graph, give it a start, give it the end, ask it to complete the code here, how likely do you think GitHub Copilot is going to correctly auto-complete a shortest path algorithm based on the function definition? Thoughts? Who thinks it is going to correctly auto-complete a shortest path algorithm? Okay. Who wants to tell me why? Yeah, that's valid. That's a valid guess, right? What shortest path algorithm do you think is going to autocomplete? Dijkstra. Okay, well, everyone knows what Dijkstra is, right? Given a weighted graph, it's going to give you the shortest path from one node to another. Yes, possibly, but let's take a look at, what are the intricacies of this? First of all, I haven't even specified what graph is supposed to be. What are possible graph representations? Who can give us a quick kind of lecture on that? Yes. Adjacency list or adjacency matrix. Well, that's right. We're like, okay, I have a shortest path over here. I haven't even specified. And actually, in here, yeah, that's two representations. But other representation is just graph object, right? Just nodes and edges with pointers. Is another possible shortest path representation. Another shortest path graph representation, right? Second of all, similarly, I haven't defined what the start is. I haven't defined what the end is, right? Not great. I've also not defined what is the output, right? Shortest path could be talking about the weight, right? What is the final weight? Could be talking about the path. Could be about how long is the shortest path, right? GitHub Copilot needs all the context in order to actually do it properly, right? I'm not saying that GitHub Copilot cannot autocomplete Dijkstra. It very well can. But what if I told you the graph is an unweighted graph? Just all the edges are 1. Now you've completely over-engineered your solution with the priority queue with Dijkstra, where all you need is actually just a breadth first search, right? All depends. Okay. Case 2. Let's kind of like add to it, and I like the point where everyone not everyone has taken C73, but my case 2 is what if my graph has edges with negative weights, and hopefully we all know that Dijkstra doesn't work. Good. We've learned everyone's learned C73. Okay. That will give the shortest path. What do we do here? Do we prompt? Can we really realistically prompt GPT to say, oh, my code doesn't work? Probably not. Who knows how to solve this? What is the correct algorithm that we need to use to handle graphs with negative weights? Yes. Bellman-Ford. There we go. Right? Again, when you've kind of like go into GPT autocompletion, it's actually very good to have your fundamentals, right? When you go into the situation, you get because in Dijkstra won't error out for the shortest path if you have graphs with negative weights. It's just going to give you the wrong path. It's going to give you an arbitrary path, right? It's a path, not the shortest path, right? So in this case, if I go here, my case 1, again, is about constraints, right? What do I need? Okay, I need a graph. My graph is an adjacency list. Oh, my graph is an adjacency list with the weights that could possibly be negative, right? And we're over here, right? Bellman-Ford. Maybe if I prompt it with Bellman-Ford, it will give me better contextual things, given that I've also defined properly what my inputs are for everything, okay? And so you realize that Copilot, you can see through these two examples that Copilot will not really replace your brain. It does replace things that you don't want to do. For example, recite the Bellman-Ford algorithm, which honestly I cannot do. But can I tell GPT to write a contextual Bellman-Ford algorithm and validate that it's right? More likely, right? Let's take a look at case 3. What if you want to calculate the shortest path, but you actually need an all-pair shortest path algorithm? Okay, something like Floyd-Warshall. Because you realize that not only do you need to calculate the shortest path from point A to point B, you also need to calculate it from any arbitrary point to another arbitrary point, right? Because recently, it's a true story. Because recently, at Verto, we were doing a simulation engine which tracks agents walking around a map. And so, although a shortest path will work, and although we aggressively cache the results, it still has to perform the Dijkstra all the time. Okay, we don't have negative weights, but what GPT cannot do, again, is make these decisions for us, to make these design architecture decisions for us, to use even the Floyd-Warshall. And for those who haven't heard of Floyd-Warshall, again, you're at a disadvantage. Like, how are we going to do it? Oh, I'm going to cache my Dijkstras, right, and run it, pre-run it a billion times, right? So if I have 10 nodes, all right, run Dijkstra. What is the theoretical running time, right? Let's take a look at it, right? Like if I run Dijkstra's oops, I can never spell that, right? And again, obviously, the reason why I'm Googling it is because I do not remember the worst case performance. But here, right, like you have your O V log V, right, as the complexity. And if I were to, just make it so that I have to run this on all pair shortest path with the Dijkstra, which GPT can actually do it for you, right? If you're prompted, it was like, oh, calculate, given shortest path, calculate the shortest path from every node to every other node, right? That's the actually V times V log V, right? So something like, is it V squared log V? Something like that. Or more, right? Because you have the edges as well. So E squared plus V squared log V or something like that. But if you use something, and that's slow. Like I've realized in my simulation engine, when I do that, startup is going to take very long because I have many paths. But if you do something like Floyd-Warshall, I think it's N3, right? N to the 3. V to the 2. Oh, V to the 3. There we go. Slightly faster. Right? And it really stacks up. I think this is when, the practical elements of knowing complexity stacks up because you'll realize in your application that, oh, it's slow. How do I deal with that? Yeah. So the lesson here is you need to know what you're doing, right? If you don't know Floyd-Warshall, for example, you go back and prompt GPT, it will give you Dijkstra in the loop, right? Loop through all pairs. Sorry, and then it's not V3, V to the power of 3 times V squared times log V. It's something else because all pairs is not it's a permutation, right? You could do A to B and then B to A, right? That's a lot of vertices you have to go to. So to best utilize GitHub Copilot, what you will want is good context, right? So well-named functions. Again, I think the first time around, the reason why people think that the shortest path will work is because it's named shortest path. Oh, shortest path, Dijkstra. Okay. So name it contextually, you have a higher chances of success, right? Really good with helper functions. If you wanted to like slice a list, or if you wanted to, I don't know, do like Fibonacci sequence, I think it can do it pretty well, right? Adding types will always help, as I've tried. Like if you add types, it's more likely that it can pull the right objects for you. And also on top of that, you'll realize when you work more with GitHub Copilot that it actually tries to mimic your code. If you write bad code, it actually outputs bad code. If you write good code, it will try to copy that particular syntax and go with it. So the suggestion is try to write nicer looking code from the beginning, right? Given an empty file, by the way, GitHub Copilot really does suck, right? If you really just prompt it with this, or if you just prompt it with that, that's not going to work, okay? The rule of thumb here is garbage in, garbage out. I really like this analogy because if you put garbage in, you're not going to get anything other than garbage, okay? And yeah, that's my lecture. Thank you so much. Thank you. Any questions?